Lesson 2 is slope and perpendicular lines. So 2.1, if two non-vertical lines are perpendicular lines, then their slopes have a product of -1. And then down below it says that their slopes are opposite reciprocals. So a quick review, perpendicular lines are lines that intersect at a right angle or a 90-degree angle. And then it says that if two lines are perpendicular, their slopes have a product of -1 and their slopes are opposite reciprocals. So for example, if I have one line and the slope is 2/3, the opposite reciprocal of 2/3 would be -3/2. A reciprocal is like a fraction flipped upside down. Opposite is referring to the sign, so like the opposite of a positive number would be a negative and vice versa. And if I were to find the product between these two numbers, I could just go ahead and multiply straight across. So like 2 times -3 is -6. And then 3 times 2 is +6. And then -6 divided by 6 is -1. So their product was -1. And that's the case for any opposite reciprocals. Anytime you multiply them together, you should get -1. Okay, so we're going to prove this using similar triangles, prove that perpendicular lines have slopes that are opposite reciprocals. In this graphic, we have two pairs of perpendicular lines. There is the vertical and the horizontal line that are perpendicular, and then there's also line K and line L. Between those two, you can see that little right angle box showing that they're perpendicular as well. So within this graphic, we can kind of create triangles like we did in lesson 1 about kind of based around like the rise over run, like the slope of each line. So for line K, this would be my rise and this would be my run. Remember, rise is just like the vertical change and run is the horizontal, like side to side. And then from line L, this would be my rise and this would be my run. So rise, vertical change, run, horizontal. And then you can see I've kind of created triangles now between my rise, my run, and the lines themselves. So if we can prove that these triangles are similar to each other, it's going to help us show that the slopes are opposite reciprocals as well. So in order to prove that the triangles are similar, we need to find two pairs of corresponding angles that are congruent. So each of these triangles, the blue and the red, they both have a right angle, so that should be our first pair. So angle ACO and angle BCO as well, because those angles were created from a vertical line intersecting with a horizontal line, so it's perpendicular, so creates those right angles anywhere around that intersection point. And then the other set of angles that I want to show are congruent are this angle up here, angle CAO, and this angle right here, angle BOC. And those aren't the only ones that we can show. This isn't the only way to do this problem, but that's the ones we're going to focus on. So I think this is easier to show if we actually kind of give angle values, even though they're kind of like made up for this problem. So what I mean by that is I'm going to say that this angle is 60. And again, just kind of made up. And between these two angles, those together create a right angle, and right angles add up to 90 degrees. So if I wanted to figure out what this angle was, based on the first angle being 60, I could do 90 degrees minus 60 degrees, and that leftover angle must be 30 degrees, because 90 minus 60 is 30. And then if I keep with that trend, and now I try to find this angle, well, all the angles in a triangle add up to 180, and in that blue triangle, I have a 90-degree angle right here and a 60-degree angle right here. So if I take 180 and I subtract 90 and then I subtract 60, it's going to leave me with 30 degrees. So that must be a 30-degree angle as well. And you could technically use that same strategy to prove that the 60 and this little angle over here is also 60. It really doesn't matter which one you pick. You just have to show that two pairs, or really like our second pair of angles now, is congruent, and that's what we just did. So regardless of if the angles were 60 and 30 or 50 and 40, this angle down here, angle BOC, is always going to end up being the same as this angle up here, angle CAO. So now we have two pairs of corresponding angles that are congruent. We had those two right angles, and then now we have those two, well, they're not actually 30 degrees, but those two smaller angles in there, angle CAO and angle BOC. Okay, so I'm going to erase the 30 degrees. The biggest thing that we need is not really the angle measurements. It's just the fact that these two angles are congruent. And now we have two pairs of corresponding angles that are congruent. So that's enough to say that the triangles are similar. So now if we said the triangles are similar, we can go ahead and set up a proportion comparing the side lengths. So my first fraction is going to be a ratio between the long leg of the blue triangle over the short leg of the blue triangle. So remember, the legs are the sides of the right triangle that just aren't the hypotenuse. So the long leg would be this side right here, AC, over the short leg, which would be this guy right there, CO. So both of these legs are from that blue triangle. The numerator is the long leg, the denominator is the short leg. And that doesn't necessarily matter how I set up the first one. I just have to make sure that the second one is organized the same way. So in the numerator, this was the long leg, and then this was the short leg. So I'll have to organize my second fraction exactly the same. So this one will be based off that red triangle. So the long leg of the red triangle, it's kind of hard to see, but it's not like this one. It's actually that little guy inside there. That diagonal one, this one, that's the hypotenuse. So the long leg of the red triangle is CO. And then the short leg of the red triangle is, I know it's really tiny now, is BC. So because the triangles were similar, that means their side lengths are proportional. We set up a proportion with long leg over long leg, long leg over short leg of each triangle, and these values are equal because the triangles are similar. Okay, so now I'm going to erase some of the clutter a little bit, and we're going to step kind of, not away, but show what this means in terms of like the slopes. So if we look at the slope of line L, so I'm going to say M, like M for slope, of line L. Well, M is equal to rise over run, and the rise was right here. So that was AC. Over the run was, let's see, it was inside here. Let me see how small I can write it. But the run was that horizontal change. It was CO. So now if you look, like, these are the same. So that proportion that we set up for the blue triangle ended up being the same as the slope of the blue triangle, just kind of by chance. And then we can find the slope for the red triangle now, or not the red triangle, but the red line, excuse me. So M of K, slope of line K. So same thing, slope is rise over run. So the rise for line K was right there. It's the vertical change, that's BC. Over the run of line K, that's the horizontal change right here, which is CO. And then the one thing that we have to consider before we get to the end of this problem is that slope is like directional. So you have to include negatives if something is like decreasing, and slope is decreasing when it's going down and to the right. So if we look at like the blue line is going up and to the right because the rise is going upward, but the rise on the red line is going downward. So it would be a negative slope. It would be negative BC over CO. So then now if we go ahead and compare what we got for the slope of line K with our proportion, it's not only the opposite sign because our proportion dealt with a positive value or a positive fraction. It's opposite sign because of the negative, and it's just that fraction flipped upside down. So like this was CO over BC, this is BC over CO, so it's the opposite reciprocal. So that means that the slope of line L is equal to the opposite reciprocal slope of line K. So I'm going to say opposite reciprocal, and shorten it like that, of the slope of line K. And that's for all perpendicular lines. Their slopes will be the opposite reciprocal of each other. Okay, so proofs, like whenever you're trying to prove it, usually end up being the hardest version of whatever we're trying to learn. So just know this is how we prove it, but the application probably maybe won't be quite as challenging. Okay, so example 1. Find the slope of a line perpendicular to a line with a given slope. So if two lines are perpendicular, that means that their slopes are opposite reciprocals. So whatever slope we're given in the problem, we just need to find the opposite reciprocal of that. So opposite reciprocal, I'm just going to put that in parentheses. Opposite reciprocal. And opposite is referring to positive or negative, just the opposite of what you're given. And then reciprocal is like a fraction flipped upside down. So like A, B, or A over B to B over A. Okay, so example 1A, I'm going to label these as like M1, like the slope of the first line, and M2, the slope of the second line. So M1 is 1/2. So if we wanted to find the slope of line 2 and it be perpendicular to that, we'd have to find the opposite reciprocal of 1/2. So since 1/2 is positive, the opposite would be negative. And then the reciprocal of 1/2 would be 2 over 1. But if you have a 1 in the denominator, you don't need to write it. So it would just be -2. So slope of line 2 would be -2. And then for B, M1 is -3, so M2, slope of line 2, the one that's perpendicular to it, would be the opposite. So since this is a -3, our slope will be positive. And then I can think of 3 as 3 over 1, and then that's what I take the reciprocal of. So if I flip that upside down, it'd be 1/3. So the slope of line 2, the one that's perpendicular to the original one, would be 1/3. And then for C, for M1, it's -5 over 4, 5/4. So the slope of line 2, since this was negative, our new slope will be positive. It's the opposite sign. And then we take that fraction and we flip it upside down. So it'd be +4/5. So slope of line 2 would be 4/5. And then for D, it says a line passing through 5, -1, and -2, 5. So this one we're not really given the slope first, but we have to find it. So we do have the tools to find it. We have a slope formula. So slope formula is M equals y1 minus y2 over x1 minus x2. And remember, it doesn't matter which point you make your like point 1 and which one you make your point 2. That went too far. I'm going to say this is my 1 and this is my 2. So this will be x1, y1, x2, y2. So we'll take -1, put it in for y1, and then 5 and put it in for y2, and then another 5 and put it in for, sorry, the double 5 threw me off. 5 we'll put in for x1, and then -2 we'll put in for x2. We just have to be careful with the negatives. So y1 is -1 minus y2 is 5. So -1 minus 5. And then in the denominator, x1 is 5. And then minus x2 was -2. So there's going to be that double negative there. And then now in the numerator, if I subtract -1 minus 5, it's like I'm starting at -1 and going down 5. So I'd be going down 6. And then in the denominator, 5 minus -2 is like 5 plus 2. Double negative turns to plus. So it'd be 5 plus 2, so 7. So this is the original slope, M1. So if we want to find the slope of line 2, I have to find the opposite reciprocal of -6/7. So instead of negative, it would be positive, and then I would flip the like 6 and 7, and it becomes 7/6. So M2 equals 7/6. And then for example 2, determine if the following lines are perpendicular. So line R, the equation for that line is y equals negative 1/3 x plus 4, and then line N, that passes through negative 6, negative 1, and negative 7, negative 4. So we just need to find the slopes of each individual line and then compare them and see if they're opposite reciprocals. So for line R, this is in slope-intercept form, which is y equals mx plus b. And m has the same meaning as everywhere else, it's the slope. So in order to find the slope, we got to figure out, okay, where is m in the formula? It's in front of the x. In order to find it here, we look at the number in front of the x, which is that negative 1/3. So the slope of line R is negative 1/3. And then now we'll find the slope of line N and see if they are opposite reciprocals. Okay, so I'm going to copy the same slope formula down here. So m equals y1 minus y2 over x1 minus x2. And again, it doesn't really matter like which one is your point 1 and which one's your point 2. On these points, like all the numbers are negative, so I don't think it makes a big difference either way. But I'm going to say this is my like point 1, this is my point 2. So this will be x1, y1, x2, y2. So we'll put negative 1 is going to go in for y1, and then negative 4 is going to go in for y2. Negative 6 is going to go in for x1, and then negative 7 would go in for x2. This would be a good one to like kind of pause and test yourself if you feel comfortable, and then play through the video to check your answer. So y1 was negative 1, and then minus from the formula y2, which was negative 4. And then, so negative 1 minus negative 4. And then x1 was negative 6. And then minus x2, which was negative 7. And then we got a bunch of double negatives here, so they all turn into plus. I'm just going to go ahead and write that in the next line as opposed to like above and below. So next would be negative 1. And then the minus negative 4 turns into a plus 4. And then the minus negative 7 would turn into a plus 7. So it'd be negative 6 plus 7. And then now if I add in the numerator, negative 1 plus 4 is the same thing as 4 minus 1. You can always like switch the order like that. So it's 3. And then negative 6 plus 7 is the same thing as 7 minus 6. You can always switch the order. And so it's just 1. So we end up with 3 over 1. So that's our slope of line N. And you could write it as 3 or 3 over 1. It doesn't really matter for this problem because we're just supposed to determine if the slopes are perpendicular. So we're comparing these two and seeing if they're opposite reciprocals. So one was negative 1/3 and the other was positive 3 or positive 3 over 1. So they're opposite signs, positive, negative, and then 1/3 and 3 are reciprocals of each other. So we can say yes, they're perpendicular, and the like shorthand for perpendicular is this symbol, like a vertical line and then a horizontal line at the bottom. Okay, moving down to 2.2. So equations of perpendicular lines. For this section, we need to just like review the equations or formulas that we reviewed in lesson 1. One was slope-intercept form, which is y equals mx plus b. One is point slope form, which is y minus y1 equals m times x minus x1. In slope-intercept form, or really in both, m represents the slope. And then where they differ, in slope-intercept form, you're given the y-intercept in b. And then in point-slope form, you're given a additional point. So x1, y1 would be that additional point. Okay, so there are 2 examples. I'm going to use one form for each example. If you have one that you've already decided that you prefer, you can use it for both. Just make sure we get the same answer in the end. Okay, so example 1, find an equation for the line that is perpendicular to the given line and passes through the given point. So 1a is line AB contains points A, negative 1, 8, and B, 8, 5. And we want to write an equation that's perpendicular to that line and passes through the point C, 3, negative 7. So for A, I'm going to use slope-intercept form. So the very first step that we need to follow is we need to find this slope. So we need to find the slope of the original equation line AB. So I'm going to say, or we'll just write it as like the slope formula of like line AB, and that'll be representing like this line AB, same thing. And then let's see if my slope formula is still, oh, cool. Okay, sorry, it's kind of like cheating, but makes you guys have to wait less time to write it down. Okay, so the slope of line AB, the slope formula is y1 minus y2 over x1 minus x2. Again, doesn't matter which point is which. I'm going to say that this is my point 1 and this is my point 2. So this will be my x1, y1, let's see, x2, y2. Sorry, that's kind of squeezed in there. Okay, so y1 is 5, and then y2 will be 8, and then x1 is 8, and x2 is negative 1. So y1, 5, minus y2, 8, so 5 minus 8, and then in the denominator, x1 was 8, and then minus x2 was negative 1. So that double negative is there. And then now we can simplify. So 5 minus 8, if we start at like positive 5 and go down 8, we land at negative 3. And then 8 minus negative 1, that double negative turns into a plus, so turn into 8 plus 1, which is 9. And then if we can reduce it, we should. So like each of these is divisible by 3. So I can divide each of those by 3 to reduce the fraction. Negative 3 divided by 3 is negative 1, and 9 divided by 3 is 3. So the slope of line AB is going to be negative 1/3. Step 2 is going to be, I'll just add it in here actually. So step number 2 is to find the opposite reciprocal. So I'm going to say, I'm like trying to decide what we want to call our new line. I'm going to call it line C, just because it passes through the point like C3, negative 7. So the slope of line C is got to be the opposite reciprocal of negative 1/3. So since it's negative, our slope will be positive, and then the reciprocal of 1/3 is 3. So the slope of our new line is going to be 3. And then step 3 is going to be to put that slope into y equals mx plus b. So we'll take that slope that we just found, 3, and put it in for m in that formula. So it'd be y equals 3x plus b. And then we have to figure out what b is for our final answer. In order to solve for b, we need that to be like our only unknown. So step 4 is to take that new point. I'm going to erase some of this like clutter up here. To take that new point and put it in for x and for y. So we'll take 3, put that in for x, and then take negative 7 and put that in for y. I'm just going to draw an arrow that's saying we're plugging it in. So 3 is going in for x, negative 7 is going in for y, and then that'll leave us with our only unknown. So negative 7 replaces y. 3 times 3 goes in for x plus b. And then now we can go ahead and simplify. So we'll multiply these two together. So it'll be negative 7 equals 3 times 3 is 9 plus b. And then our goal is to get b by itself. So I have to cancel out that 9. So I'm going to subtract it over. Negative 7 minus 9 is negative 16 equals 9 minus 9 cancels out. So equals b. And then our final answer we find by just taking that like 16 that we just got for b and putting it into the actual equation where b is. So our final answer would be y equals 3x and then plus b, but b was negative 16, so b minus 16. So y equals 3x minus 16, that is the equation of the line that is perpendicular to the given line but passes through 3, negative 7. Okay, so for B, same type of problem, it's just we're going to use a different formula for this one. So this time we're supposed to find a line that is perpendicular to the line that contains these points and passes through -1, -3. So line AB contains points 1, 5, and 2, 7. We want to create the equation of a line that's perpendicular to line AB and passes through -1, -3. So the first step is the same. We got to find the slope between those 2 points. So I'm going to say same thing, slope of line AB, and it's referring to that original line AB from that first line. And then it does not matter which point we make, point 1, point 2. I'm going to make this point 1 and this point 2. So I'm going to try not to label it this time just to kind of get us more comfortable with moving through a little more quickly. So y1 is 7. So y from the first point is 7 minus y2 is 5. And then in the denominator, x1 is 2. The x from point number 1 is 2. And then x2, the x from point number 2 is 1, so minus 1. And then we can subtract in the numerator. 7 minus 5 is 2. Over 2 minus 1 is 1. So our slope is 2 over 1. And then for the second step, we need to find the opposite reciprocal of that number, because we want our line to be perpendicular. If we wanted it to be parallel, we would just keep that same slope, but we want it to be perpendicular, so we need to find the opposite reciprocal. So I'm going to do it the same way here. I'm going to say the slope of line C is going to be like my new line that I'm trying to find. The opposite reciprocal of 2 over 1, since 2 over 1 is positive, it'd be negative. And then we flip 2 over 1 to 1/2. Okay, so that's my slope for my line. So step number 3 is going to be almost the same, but we're using a different formula. So put in point slope form, which is this one all the way up here. So it's going to be put in y minus y1 equals m times x minus x1. And again, I don't care which way you do it. I just want to give as many examples as possible of each method. So we're going to take our -1/2 and put it in for m. So then it would be y minus y1 equals -1/2 times x minus x1. And then now our next step would be to go ahead and take that point that's supposed to be on our line, which is our line was supposed to pass through -1, -3. So that's got to be our x1 and y1. So let's see, I'm going to put step 4 up here. Step 4 is to take this point, put it in for x1 and y1. So x1 will be -1, y1 will be -3. So -1 right there, and then -3 right there. So we'll take that point and plug it in. Okay, so y minus y1, or yeah, y minus y1. Y1 was -3, so we'll have a double negative there, and then equals -1/2 times x minus x1. X1 was also -1, or not also, but it was -1. So another double negative. We'll simplify our double negatives. So y minus -3 turns into y plus 3 equals -1/2. X minus -1 turns into x plus 1. And then from there, our ultimate goal is to get it into slope-intercept form. So to do that, we'll have to simplify the right side, meaning we'll distribute. So I'll leave the y plus 3 and then distribute -1/2 times x is -1/2 x, and then -1/2 times 1 is -1/2. And then from there, I think just to make life, no, okay, I'm not going to make life easier. I was going to change it to a decimal, but we can handle it with fractions. From there, we want to get y by itself, so I have to cancel out this plus 3. So I'm going to subtract 3 from both sides. But I'm subtracting it from like this 1/2 right here. So I have to get a common denominator. So instead of 3, I'm going to write it as 6/2. So minus 6/2. And if you ever need to get a common denominator, you take your number and you multiply it by, like, in this case, we want our denominator to be 2. So I'd multiply it by 2/2, and then that would give me 6/2. So like these are equivalent, just now I have the common denominator. So then I would bring down my y. 3 minus 3, that cancels out. I bring down the negative 1/2 x. And then now I can subtract my fractions. When you subtract fractions, you just subtract the numerators. So it'd be like -1 minus 6. -1 minus 6 is -7. And then the denominator stays the same. So -1/2 minus 6 halves would be -7 halves. So altogether, final answer is y equals -1/2 x minus 7 halves. So again, just two different ways of doing like the same exact problem between the like different formulas and stuff. It's really just personal preference what method you like more. I would try to be fairly comfortable with each one though, just in case you ever are given like one of those like step-by-step problems and they use like one specific formula rather than giving you free reign to do the problem.